So in the third lecture on our discussion of memory, we're going to talk about the three processes of memory. Now we've talked about the capacity and the different types of memory, but what we haven't talked about yet is how do we get information from our short-term memory into more permanent storage in our long-term memory. So there's three major processes of memory: encoding, storage, and retrieval. Encoding involves getting information into memory. Storage involves keeping information in our memory, and retrieval involves reactivating or reconstructing information from our memory. So let's go through these one at a time. First, I'm going to show you an example of the three processes. So imagine that you're a librarian and you get a new book in. So you might first enter the catalog info, you enter the call number, you print out a label so everyone knows where to find the book and how it should be stored. This is the process of encoding, or sort of compiling all of the information. Next, the librarian would determine the section of the library where the book belongs and file it away in its proper place. So if it's a fiction book, it goes in the fiction section, a history book would go in the historical section, etc. This is the process of storage, or storing the memory. Now, a few months later, someone comes in and wants to check out that book. Well, the librarian can very easily go to the catalog and call number, identify where the book is stored, go to the correct book, and voila, there it is. They can retrieve the book. This is a bit of an oversimplification of the process, but I think it's a pretty clear-cut and easy to follow example. So hopefully it gives you a general idea of how memory works. So now let's go through each of the processes in a little bit more depth. So encoding is the process of getting information into our memories. Most events that we experience are never encoded. If we were to encode every single event that happened in our lives, we would just have information overload. We'd be burdened down with all of these unnecessary, useless memories that don't really serve any purpose for us. When we do encode events, sometimes only some of the details of the experience actually make it in. So this explains why sometimes even after meeting someone a few times, you still can't remember their name. Perhaps you were attending to other parts of the event, and in the encoding process, their name just never quite made it through. So that's an important note. To encode events, we must first attend to or pay attention to them. Now, there's a popular misconception that our brains preserve a record of all events we encounter, and then sort of this idea that you can unlock those buried memories. That's not really true, because what that means is that we'd have to pay close attention to every single detail of every single thing in every single event, and that's just not possible. So here's a good example. You've all seen pennies throughout your life, but here I'm showing you a bunch of pictures of pennies that all have subtle differences. Can anyone tell which is the correct one without looking it up or looking at a real penny? If you were able to encode every detail of every event, you would just be able to dig through your long-term memory and pull out the correct answer. But I'm thinking that the majority of you can't do that. I certainly couldn't. The correct answer is B, by the way, in case you're wondering. Encoding also helps explain the next in line effect and memory for common objects. So say you're in class, the teacher is calling on students row by row to answer questions. So you probably remember what the first few students said, but as it gets closer and closer to you, you might blank on what the students right before you say because you were so preoccupied with thinking about and rehearsing what you were going to say that you just weren't listening to what they were saying. Storage is the process of keeping information in our memories. So how we store experiences in memory depends on our interpretations and expectations. One thing that affects storage is schemas, which are organized knowledge structures or mental models that we've stored in a memory. So one example of a schema that you might have is what happens when you go into a restaurant. So there's sort of a script that we can follow. You go in, you go up to the hostess, you tell them how many people are in your party, you wait for them to show you to a table, you sit down, look at the menu, talk to the server, decide what you want to eat, right? It'll vary a bit based on the type of restaurant, but as a general rule, that's the script that we would follow in a sit-down place. Schemas affect how we store memory information and equip us with frames of reference for interpreting new situations. They're useful, but they can sometimes lead to memory mistakes. For example, schemas can lead us to remember things that never happened. This can be good because it helps us to make sense of the world, but schemas are often prone to oversimplification, which is bad because it can produce memory illusions. This goes back to the idea of that paradox of memory. Sometimes it's very good, but other times it can be very poor and not helpful. Remember in the first lecture how I showed you the words and the word sweet wasn't there? Memory paradox. Last up is retrieval, which is the reactivation or reconstruction of experiences from our memory stores. To remember something, we have to fetch it out of our long-term memory bank. Many types of forgetting result from failures of retrieval. But some things can help with this, such as retrieval cues or hints that make it easier to retrieve the information. So say you're trying to teach a child how to count to 10, and they're doing okay, but they're struggling a little bit. They get 1, 2. You might prompt them by going 3, which can then jumpstart their ability to dig 4 out of their long-term memory. Measuring memory makes use of the 3 R's: recall, recognition, and relearning. Recall involves generating previously remembered information. Recognition involves selecting previously remembered information from an array of options. Recall tends to be more difficult than recognition because it requires both generating an answer and determining whether it's correct, while recognition only involves determining which answer from a list seems correct. Think about when you're given a multiple choice exam versus a short answer exam. With recall, you could be completely off the rails, but with recognition, you typically have at least a 1 in 4 shot of getting the right answer. Relearning requires knowledge that we've previously learned, but largely forgotten over time. A good example is a musical instrument. Anyone learn to play an instrument when you were younger and then give it up? I did. I played the piano my whole life growing up. And then when I got to high school, it was just too much to manage. I was having to practice 45 minutes every day. And I wanted to spend time with my friends, and I had homework. And so something had to give. And I stopped playing the piano. Now, later in my life, I am not nearly as good as I was when I was younger, but if I were to sit down and try and take up playing the piano, it would be a lot faster for me than somebody who was brand new to playing it, because I'm not learning the piano, I'm relearning the piano. Another important point is that we remember things better when we spread out our learning over larger intervals. This is really important to remember for studying techniques. Cramming is simply not an effective means of learning and is very difficult to remember. You're better off taking 10 minutes a night and studying the material than trying to cram it into one small period of time before the exam, because we simply remember things better when learning is spread out. So file that away for your next exam. Let's do a quick example of recall versus recognition. So if I asked you, what's the name of the Disney princess who wears a yellow dress? You not only have to pull the information out of your long-term memory, but you have to identify whether or not the answer is correct. Here, I'm now giving you choices, so you don't have to pull the name out anymore. You know it's one of those 5 options listed here. And in case you're wondering, the answer is indeed Belle. A retrieval failure is where we are sure we know the answer to something but can't quite come up with it. One example of this that you've probably experienced is called the tip of the tongue phenomenon, which is an experience of knowing that you know something but you're just unable to access it in that moment. Anyone ever watch Jeopardy? I love watching Jeopardy. And a lot of times I will know the answer to the question, but I just can't quite get it out fast enough. It's a good example of retrieval failure. It tells us that there's a difference between something we've forgotten because it wasn't stored in a memory and something we just can't quite retrieve. And what's interesting is that we're really super accurate. When you have that feeling like something's on the tip of your tongue, you're usually right with what you're going to say. You're just having a hard time saying it. Encoding specificity is the phenomenon in which the conditions under which we try to retrieve information are similar to the conditions in which we've encoded it. There's 2 kinds: context-dependent learning and state-dependent learning. With context-dependent learning, we're better at retrieving something when the external content of the original memories matches the retrieval context. So, for example, students tend to do better on exams when they're tested in the same classroom in which they've learned the material. Right? So that's good for all of you to know, even though you're learning at home, at least in my class this semester, it's a good idea to have a designated study spot and to take the exam in the same spot, because then you can lean on this context-dependent learning. Another fun example is that researchers have done studies and found that divers who learned words underwater actually recalled them better underwater than they did on land because the context was the same. State-dependent learning is superior retrieval of memories when the organism is in the same physiological or psychological state as it was during encoding. So I'm certainly not advocating that you try this, but an example is that if you learn to do a task while intoxicated, you might be better at performing that task while intoxicated than while sober, because it's mimicking the original state. But again, please don't try this at home. So up next, we're going to talk about the biology of memory, so some of the brain functioning, and also how memory develops across the lifespan.